Deep in the heart of the Congo River, engineers are attempting something unprecedented. The Grand Inga Dam, potentially the largest hydroelectric project in the world. Once completed, it could generate over 40,000 megawatts of electricity, enough to power half of Africa, more than the combined capacity of the Hoover Dam and China's Three Gorges Dam. At a staggering cost of $80 billion and spanning decades of planning and construction, this megaproject is set to redefine energy, economies, and lives across the continent. But the path forward is filled with controversy, engineering hurdles, political complexities, and social challenges. Africa faces one of the most severe energy crises on the planet. Over 600 million people live without access to reliable electricity, and by 2030, this could rise to 700 million. Blackouts plague cities such as Lagos, Kinshasa, and Nairobi, while rural communities remain in darkness. Industries struggle to operate efficiently, hospitals face power interruptions, and millions of households rely on polluting fuels like kerosene and firewood. The continent's energy demand is projected to double by 2040, driven by population growth, urbanization, and industrialization. Fossil fuel power plants are expensive, polluting, and increasingly insufficient. Small-scale renewable projects alone cannot meet the scale of Africa's demand. This is why the Grand Inga Dam, a single mega-project harnessing the Congo River, has become a beacon of hope for energy security and continental development. The Grand Inga Dam is situated at Inga Falls on the Congo River in the Democratic Republic of Congo. The river is the second largest in the world by discharge volume, averaging 42,000 cubic meters per second annually, with peaks reaching 25,000 cubic meters per second during rainy seasons. Hydropower development at this site dates back to the 1920s when colonial engineers first surveyed the potential of the river. Construction of Inga 1 began in 1968 and was completed in 1972, generating 351 megawatts, followed by Inga 2 in 1982 with 1,424 megawatts, bringing the combined capacity to 1,775 megawatts. While impressive at the time, these early plants exploited less than 5% of the river's potential, leaving room for a far more ambitious project. The new phases, Inga 3 and the Grand Inga expansion, aim to generate 40,000 megawatts, making it the largest hydroelectric project in history. The project will feature 145 massive turbines, each producing hundreds of megawatts. Reservoirs will cover hundreds of square kilometers, submerging lowlands but providing enormous hydropower storage. Transmission lines stretching over 5,000 kilometers will carry electricity across Africa, from the DRC to South Africa, Nigeria, Angola, and Zambia. The estimated cost is $80 billion, making it one of the most expensive infrastructure projects ever attempted. Construction has faced repeated delays due to political instability, corruption, and funding issues. The African Development Bank, World Bank, and international private investors are now backing the latest phase, aiming for completion of Inga 3 by 2035, while the full Grand Inga vision could take 15 to 20 more years. Engineering this mega project is a monumental task. The Congo River experiences extreme seasonal variations, with peak flows of 25,000 cubic meters per second. Turbines and spillways must withstand immense water pressure, heavy sediment loads, and powerful currents. Concrete requirements are enormous, over 100 million cubic meters, enough to build hundreds of Eiffel Towers. Excavation and tunneling must navigate unstable geology, dense rainforests, and seasonal floods. Construction teams face logistical challenges, including remote access, heavy rainfall, and tropical storms. Transmission infrastructure is equally ambitious. High-voltage lines must cross mountains, forests, and swamps, requiring advanced engineering solutions to prevent energy loss and maintain grid stability. Engineers also plan for redundancy and emergency systems to avoid large-scale outages across multiple nations. Environmental engineering is a critical component. Sediment management, aquatic ecosystem protection, and flood control must minimize long-term ecological impacts. Innovative designs like fish ladders, sediment flushing systems, and managed wetlands aim to reduce environmental disruption. Water management is also crucial. The reservoirs must balance electricity generation with flood control downstream, protecting communities along the Congo River while maintaining reservoir capacity for peak demand. The Grand Inga Dam could transform Africa's energy landscape. Full operation could supply electricity to 600 to 700 million people, powering homes, schools, hospitals, and industrial zones. Economists estimate the project could increase GDP by tens of billions of dollars annually, creating millions of jobs during construction and operation. The dam could also attract foreign investment, stimulate industrial growth, and provide energy independence to countries currently reliant on expensive imports. It is projected to cut millions of tons of CO2 emissions per year, making it a critical step towards sustainable development. Social costs are significant. Reservoir creation could displace tens of thousands of people, submerge farmland, and affect biodiversity. Authorities are developing resettlement plans and environmental impact strategies to reduce human and ecological harm. The project also strengthens regional cooperation. Electricity export agreements with South Africa, Angola, and Zambia will promote economic integration and stabilize regional energy markets. The project's political and financial complexity is immense. Multiple governments, international donors, and private investors are involved. Questions over energy distribution, governance, and equitable access remain unresolved. Environmental groups warn of habitat loss, wetland flooding, and species disruption. Critics argue that smaller, decentralized renewable energy solutions like solar, wind, or microhydro could be deployed faster and at lower cost. There are also logistical risks. Civil unrest, corruption, and supply chain issues could delay or inflate costs. Even natural disasters like floods or earthquakes pose threats to the dam's integrity. Geopolitical factors also play a role. Neighboring nations must agree on electricity sharing, while international investors demand transparency and security for their capital. Proponents argue that despite these risks, only a mega project of this scale can satisfy Africa's projected energy demand for decades. It is a high-risk, high-reward endeavor with transformative potential. The Grand Inga Dam is more than an engineering project. It is a symbol of human ambition, continental development, and the power of infrastructure to change lives. It has the potential to provide electricity to hundreds of millions, reduce dependence on fossil fuels, stimulate industrial growth, and position Africa as a global renewable energy leader. Yet failure could result in wasted billions, environmental damage, and continued energy scarcity. The Grand Inga Dam is a mega project that will define an era, a bold attempt to harness one of the planet's most powerful rivers to shape Africa's future. Its success or failure will echo for generations, symbolizing both the promise and perils of mega project engineering. This is a story of ambition, resilience, and transformative engineering. The Grand Inga Dam may not only power a continent, but also rewrite the rules of what humanity can achieve with water, energy, and international cooperation.